welcome to Info 3370, studying social inequality with data science at Cornell. So in this course, we're currently, if you pull down the topics in income inequality, we've just learned how to use R, and we're about to learn a bit about color and facet. So those will be our tasks for today. Today we'll be using a group exercise to study income inequality by education, and we have a few learning goals. So our goals are first to practice more with ggplot. So each table group created their own ggplot today. Then we're going to learn how to distinguish multiple trends in a single plot using colors and facets. And then finally, we worked on communicating the results in a few sentences. So for those of you who aren't in class, we're analyzing this dataset by college.csv, which is available on the course website and is also listed below. So before we got started, we coordinated a little bit within our groups. So we decided to assign one person in each group to be the coder and one person in each group to be the writer. And so this is described here in part 1 on the course website. So we first created a vector of names for the people at the table. And you see these names stored here. And we assigned that vector of names at the table to an object in R that we called names. And so every table did this for their own names. And then we used the sample function. If you want to learn about the sample function, you can type question sample into your console and then hit enter, and you'll get the help file for the sample function. So what it does is the sample function takes as arguments two key pieces here. So the first is the vector of names that we just created, and then a size, which is the number of names that are going to be sampled at random from that vector. So here we're going to sample 2 names. And we run the sample function and store the output in an R object called chosen. And so then at every table, we looked at the chosen object. And in the chosen object, we had 2 names. So the first person was assigned to be the coder, who was going to be the primary person typing R code in class today. And the second person is assigned to be the writer, who wrote up the interpretation of the result that the group collaboratively decided on. So if you're following along at home, you will be both the coder and the writer while you're following along. So then the rest of this document goes through the instructions for the class exercise today, which took almost all of the class time. So there was first some steps to code to visualize the data, and then there was this section down here about writing a few sentences to interpret the result and communicate to someone who perhaps hadn't seen that plot. So let's come up here and copy these lines for starting out the exercise, and then I'm going to come over here to R and paste those in. So the first thing we're going to do is load the tidyverse, which is that package of software that we often use in R to have access to more functions. Then I'm going to load this data set by college. And the very first thing I had everyone do is to look a little bit at the data. So we can see how many columns are there in this data set. There are 4 columns. How many rows? We have 360 rows. And then if we look at the data, we can see some information about it. So these 4 variables in this data set are year, education, income, and quantity. And we can see down here in the table that year and income are double variables, so they contain numeric values. And then education and quantity are each character variables. So the way we created this data set was by taking the current population survey provided by the Integrated Public Use Microdata series, and we looked at this current population survey's annual social and economic supplement for every year from 1962 to 2022. And within every year, we split the population of those working for 50 or more weeks in the past year into 2 subpopulations, those who held a college degree and those who had less than a college degree. Then in each of those subpopulations, we took the 10th, 50th, and 90th percentile of the income distribution. So that's the income value such that 10% of people earn less, 50% of people earn less, and 90% of people earn less. And we use these data to visualize how inequality has changed over time for those with and without college degrees. So if you go to that instructions page on the website, you see that the first task is to create a ggplot. So as before, we're going to start with the ggplot command, which has 2 key arguments. So the data argument, here we're going to use the by college data frame, and then the mapping argument, which tells the plot what variables to put where. So let's start here with x equals year and y equals income. And then we'll add a geom to that plot just as we did on Friday. So here I'm using geom point. And when I run this code, we can see the plot over here on the right. And as you see, there's a lot going on in this plot. So there are like about 6 trends here, and we'd like to distinguish those trends. So the first tool we learned to distinguish the trends is with colors. So let's add a new aesthetic here for color. And color is great, especially when you have factor variables or categorical values for your variable that you want to distinguish in the plot. So in this case, suppose we say color equals quantity, and then run the plot again. And so now we get this little legend over on the right side of the plot that tells us that we have one series for the 10th percentile, one for the 50th, and one for the 90th percentile. But our plot still isn't quite complete because we have still 2 trends that are blue, 2 that are green, and 2 that are red. So we want to somehow distinguish in the plot another categorical difference, which in this case is whether the people being summarized have a college degree or not. And so we did that using the facet wrap command. And you can learn about facet wrap in the R4DS textbook, which is linked from the course website. So here we want to do facet wrap by education. And so now we can see a clearer trend. So we have the trend among those with a college degree represented in the left facet here, and among those with less than a college degree represented in the right facet. And then many groups also added a smooth here to help make the trend a little clearer. Okay, and then there were a few aesthetic changes that many groups decided to carry out. So one of those would be to label the y-axis. Actually, let's start with labeling the x-axis. So we're going to use scale x continuous, name equals year, and we'll leave those breaks as they are. So now we'll see that we now have a capital Y on year in the x-axis. Okay, and then we wanted to work on the y-axis a little bit. So many groups came up with names such as annual wage and salary income, because the course website will tell you that that's what's measured by this variable. And in this case, we're measuring that in 2022 dollars. And here, as I did on Friday, I'm using this little /n character to create a new line in that axis label. Okay, then a final step we might want to do would be to modify the y-axis to show things in dollar values. And for that, we're going to rely on a function that's in the scales package. So if you don't have the scales package installed, you can type install.packages scales to install that package. Once we have the scales package installed, we can modify the labels here so that they are passed through the function labeled dollar that comes from the scales package. And that function adds a $sign on the front and a comma every 3 digits in the dollar value indices. Okay, and so here we have our trends. So after folks made their plots, then the next task was to interpret those plots and to actually write out several sentences interpreting what we see. So at the end of class, we had a discussion in the whole room about what was going on in this visualization, and a few things were emphasized. So one thing that's really apparent is that the 90th percentile of wage and salary incomes increased a lot over time for those with a college degree. In fact, by 2022, it was about $175,000 compared to closer to $125,000 back in 1962. Meanwhile, for all of the other trends summarized, the trend is very flat. So the median wage among college graduates and the 10th percentile among college graduates showed almost no change at all. And likewise, among those with less than a college degree, the trend is also very flat. This tells us something interesting about how inequality has changed over the latter half of the 20th century. In particular, it's changed by a rise in the incomes of the top earners who have college degrees, and relatively stagnant pay for those in the other categories depicted on this plot. Another thing that folks noticed is the similarity between these two curves. So a few people pointed out how it's remarkable how the 90th percentile among those without a college degree is about the same as the median among those with a college degree. So while there are college-educated workers earning less than some non-college educated workers, there's still much higher range to the pay distribution for those with a college degree than to those without a college degree. So overall, an interpretation of this plot is that a college degree has long been an important stratifier of incomes in America, and it has become especially important as a distinguisher for which groups were able to see really rapidly rising incomes over the second half of the 20th century, and the other groups that had incomes that were relatively flat. Now, there are some aesthetic choices that different groups made differently. So some groups decided instead to visualize this with education represented by colors and these quantities represented by facets. And this is also a totally legitimate way to visualize the results, and I think it highlights perhaps different aspects of the plot that come out to you most apparently when you look at this version of the plot. And finally, at least one group wanted to change the label on this axis over here. So they achieved that by using scale color discrete, which is just the same kind of thing as scale y continuous and scale x continuous. So this controls the color scale. And in this case, we could say the name of that scale might be like education category. And so there we have an education category. So hopefully from this exercise and through the working class, you have learned a little bit about how to use color in a ggplot and also how to use facets to distinguish particular trends in the visualization. We've now covered the core material in R4DS Chapter 1, so if you haven't read that yet, you should give it a read. We've also covered the material on visualization in Chapter 3, so that's also a good one to have read after class today. In the next class, we're going to talk about reproducibility with R Markdown. So if you jump way to the end of the textbook, in chapter 27, the textbook discovers how to use R Markdown to produce reproducible reports. And so I would encourage you to perhaps read that before class next time, or if you'd rather, you can come to class and learn the essentials in class and then read it after the next class session. So looking forward to it. See you then.